So now in this video we're gonna make a voltage ramp using a constant current source and a capacitor. And so to begin with, we will take a look at the voltages we're using. I have my bench power supply set to a little less than 8 volts, and looks like about 7.8 volts, and we have 8 squares here, and so I wanted to make sure it stays below that 8th one because the line will disappear. So we have that, and first let's remove the capacitor, and I unplugged the oscilloscope there, and you can see when we measure the current coming out of the constant current source, we're going to go to milliamps of current. Let's zoom in and get a better look right there. And so you set the current with a resistor with this constant current source, the LM334. The flat sides to the left, top pin is the V+. We have the R pin in the middle, resistor there, and then the V- right there, the other side of the resistor. This applies about 0.064 volts. This is a 68 ohm resistor, and that sets the current. But to make the math easy, this is about a 64 ohm resistor, and putting that voltage across it, we expect 1 milliamp of current. And there you can see it actually says 1 milliamp of current. Sometimes it's 0.99, but we actually got 0.1 or 1 milliamp of current on there. So 1/1000th of an amp, and that's important for this video because we're going to be charging a 1000 microfarad capacitor. It can be charged up to 35 volts. We're dealing with slightly less than 8 volts. But what that 1000 microfarad, which is the same as 1 millifarad, tells you is that for every milliamp of current that you put in here, for each second it's going to raise the voltage by 1 volt. So let's plug that to the constant current source right there, and let's bring in the oscilloscope now. And so this is pretty easy to use oscilloscope. Each one of these squares going up is 1 volt. There's 8 of them. That's why I'm keeping it below 8 volts. And I have each division here, each square, set to 1 second right there. And we are going to plug the positive side back in there. So we have this cable up on top, and it has a couple of alligator clips, blue and black, and we have them on opposite sides of the capacitor right now using these jumpers right there. And so first thing we're going to do is take, I had a blue jumper that was right here, there it is. We're going to discharge the capacitor. We're going to plug that to the negative side of the capacitor, and then this side to the positive side of the capacitor, and there you can see it instantly discharged. And so that's one reason why I'm keeping the voltage lower. Higher voltages, you see a spark and stuff. You might vaporize some metal. So there we go. It's completely discharged. So now as soon as I yank this, we will see the ramp starting right there. And when it gets towards the end, I'm going to try to stop it right when it's at a line, ideally. There we go. So just a speck before we got to the line. So let's look at this. So we didn't get much more than about 7 volts. So it takes a little more voltage than what is across the current source there, the LM334. So you lose a little bit of voltage across it. But as you can see, it looks like just a speck before this line, the voltage started going up, and then a speck before each line, so each second, we are 1 volt higher. So that's telling us we're getting 1 volt a second, and that's a steady gain until the power supply can't provide any more power through the LM334 because of the voltages that it's going to drop. But you can see it steadily goes up, and then all of a sudden it's pretty much just leveled up. So that is a voltage ramp. As long as you have enough power source voltage, the current will just keep rising steadily forever as long as you're putting a constant current into a capacitor.